Welcome back to another episode of Second Career Pilot. Today we're tackling a fundamental aspect of flying that every pilot, especially if you're just starting out, needs to really get to grips with: weight and balance.
It's definitely foundational stuff.
Think of this as your personal guide to understanding where you put things in an airplane
Yeah.
and how much they weigh is absolutely critical for a safe and successful flight.
Yep.
We'll be extracting the core principles, exploring the direct effects, and looking at some practical considerations, all stemming from the FAA's Pilot's Handbook of Aeronautical Knowledge.
Imagine you're carefully loading your car for a big trip. You wouldn't just throw everything in any old way, right?
No, definitely not.
You think about distributing the weight so the car handles properly. It's the same, but even more critical with an airplane.
Right. Much higher stakes.
Understanding this isn't just about passing your exams, It's about ensuring your safety and the safety of anyone flying with you.
Now, you might be thinking, weight and balance. Sounds a little on the technical side, maybe a bit dry.
It can seem that way at first, maybe.
But trust us, understanding this can truly be the dividing line between a smooth, predictable flight and one that throws you some serious, unexpected curveballs.
Mm-hmm.
We're going to unpack this in a way that's clear, practical, and honestly pretty fascinating when you see how it all fits together.
Absolutely.
Yeah.
And it all starts with a non-negotiable aspect of aviation: staying within the aircraft's certified weight and balance limits.
Non-negotiable.
This isn't just a suggestion.
Yeah.
It's absolutely critical to flight safety.
Okay, let's unpack this. Why is staying within these limits so important for you as a pilot?
Well, operating an aircraft above its maximum certificated weight puts immense stress on the airframe. It compromises the aircraft's structural integrity.
Okay, so you're actually damaging the plane potentially.
Potentially, yes.
Yeah.
Think of it like consistently overloading your car. Eventually, something's going to give. Maybe a tire blows or the suspension struggles.
Mm-hmm.
It's the same with an airplane, but the consequences in the air are far more serious. Beyond the structural risks, exceeding the maximum weight severely hinders the aircraft's performance.
And I imagine having the center of gravity, or CG, outside of its approved range is a whole other can of worms for how the airplane handles.
Precisely. A whole other can of worms. While exceeding the weight limit is about stress and performance, having the center of gravity outside the approved limits directly leads to control difficulties.
Control difficulties. How so?
The aircraft simply won't respond as it's designed to, and in some cases it can become, uncontrollable. Imagine trying to steer a shopping cart where all the weight is either piled way at the front or all the way at the back. It just doesn't handle right.
Okay, bad analogy maybe, but I get the picture. So let's zoom in on this idea of weight itself. In the pilot's handbook, it talks about weight as a force. Can you elaborate on that for us, thinking about how it affects an airplane trying to fly?
Certainly. Weight, in the context of aviation, is the force of gravity pulling the aircraft downwards towards the Earth's center.
Oh.
It's a direct result of the aircraft's mass.
Okay, gravity pulls it down.
Now, to get airborne and stay there, this downward force of weight needs to be counteracted by an equal and opposite force: lift.
Lift, right, generated by the wings. And I remember learning that there are limits to how much lift a wing can actually produce based on its shape and how it's moving through the air.
Exactly. The amount of lift and airfoil the wing generates has inherent limitations based on several factors. Its design, the angle of attack.
That's the angle the wing meets the air.
Right, the angle between the wing and the oncoming airflow. Then there's airspeed and also air density.
Air density, thinner air, less lift.
Correct. So if you overload the aircraft, meaning its weight becomes too great, the wings might simply not be able to generate enough lift to get you off the ground, let alone sustain flight.
Wow.
It's like a bird trying to fly carrying a stone that's too heavy. It just won't be able to get airborne.
That paints a pretty clear picture. So what are some of the specific negative effects we're talking about when an aircraft you're flying is carrying too much weight?
The list is quite significant, actually. The handbook emphasizes that any extra weight on board negatively impacts performance across the board.
Every single pound counts, huh?
Pretty much. Aircraft manufacturers go to great lengths to make aircraft as light as possible without compromising safety, because every extra pound has consequences for how the airplane will perform.
Consequences like what that you might notice as a pilot? What's the first sign?
Well, for starters, an overloaded aircraft might just not be able to take off at all.
Seriously, just won't fly.
It happens. Or, if it does manage to get airborne, it can exhibit dangerously poor and unexpected flight characteristics. The takeoff phase is often the first place where overloading becomes really apparent to you.
Okay, so what would I see?
You'll see things like a higher takeoff speed required.
Need to go faster down the runway.
Exactly. And a significantly longer takeoff run needed. Think of it like trying to sprint uphill with a heavy backpack.
Hmm.
You need more flat ground to build enough speed to overcome gravity and become airborne.
That makes sense. More mass to get moving. What happens after you're in the air if you're overweight? Does it still cause problems?
Absolutely. Several key performance areas suffer. You'll experience a reduced rate and angle of climb.
So climbing slower and shallower.
Yep, meaning it will take you longer and a greater distance to reach your desired altitude. The aircraft will also have a lower maximum altitude it can reach.
Its service ceiling drops.
Right, and a shorter overall range because it's working harder just to stay in the air. Your cruising speed will likely be reduced, and the aircraft's maneuverability will be noticeably sluggish.
Sluggish, like less responsive.
Exactly. It won't respond to your control inputs as crisply as it should.
And I can imagine that higher weight also affects the critical phases of landing when you need precise control.
Oh, absolutely. An overloaded aircraft will have a higher stalling speed.
Meaning it quits flying at a faster speed.
Correct. Which means it will lose lift at a faster airspeed than normal. This also translates to higher approach and landing speeds, giving you less margin for error if something unexpected happens.
Less room to correct?
Precisely. And once you do touch down, you'll need a longer landing roll to come to a complete stop.
Need more runway on landing too then.
You got it. The handbook also mentions the potential for excessive weight on the nose or tail wheel, which can cause its own set of problems, like difficulty in steering on the ground or even damage to the landing gear.
It sounds like you as a pilot really need to know the specific limitations and performance characteristics of the aircraft you're flying. Where do you find that information?
Precisely. The handbook stresses that pilots must be knowledgeable about how weight affects their specific aircraft model. This is where pre-flight planning and consulting the performance charts.
In the POA?
In the Aircraft Flight Manual, AFM, or Pilot's Operating Handbook, POH, yes, they become absolutely essential for you. You need to determine if the aircraft's weight could contribute to any hazardous flight operations under the given conditions, like a short runway or obstacles.
And it's not just about normal operations, is it? What about when things don't go according to plan in emergencies?
That's a crucial point. Excessive weight drastically reduces the safety margins available to the pilot.
Less wiggle room when things go wrong.
Exactly. If you combine being overweight with other performance-reducing factors like high-density altitude or adverse weather, the risks are compounded significantly for you. And in an emergency situation, such as an engine failure on takeoff or encountering airframe icing at a low altitude, it's usually too late to shed weight to keep the aircraft flying. Those extra pounds could be the difference between a safe outcome and a very dangerous one.
Wow. Okay, so the weight of the airplane isn't a static thing either, right? It can change during flight. What are some of the common ways an aircraft's weight might fluctuate that you need to be aware of?
Well, the most common variable affecting weight is the fuel load. As the handbook points out, gasoline weighs a significant amount, about 6 pounds per gallon.
6 pounds per gallon. That adds up fast.
It really does. So even something like 30 gallons of fuel can weigh more than a passenger. If you reduce the fuel you're carrying to lower the takeoff weight, you have to very carefully consider the resulting decrease in the aircraft's range.
Make sure you can still get where you're going.
And ensure you have enough to reach your destination with appropriate reserves. It's a trade-off you need to manage wisely.
And once you're airborne, the weight continues to change as you burn fuel. Does that have a noticeable effect on how the airplane flies?
Exactly. During a normal flight, fuel burn is usually the primary factor causing a change in weight. As fuel is consumed, the aircraft becomes lighter.
Which should be good for performance, right?
Generally, yes. It leads to improved performance. You might notice a slight increase in your climb rate or cruising speed as you burn off fuel.
Besides fuel, are there other, less obvious things that can affect an aircraft's weight over time that you should be aware of as an owner or pilot?
Yes. Any changes to the aircraft's fixed equipment can have a notable impact. The installation of additional radios or instruments,
Like upgrading the avionics.
right, or any repairs or modifications to the airframe or systems can alter the aircraft's basic empty weight.
The starting weight of the plane itself.
Correct. These changes should always be properly documented in the aircraft's weight and balance records, and it's the owner's responsibility to make sure this information is up to date for you as the pilot.
Okay, we've talked a lot about weight itself. Now let's shift our focus to balance and this concept of the center of gravity, or CG. What exactly is balance in this context for an airplane, and why is the CG location so critical for how it flies?
Okay, balance. In aviation terms, balance refers to the location of the aircraft's center of gravity. As the handbook defines it, the CG is the point at which the aircraft would balance if it were suspended at that point.
Like finding the balance point on a seesaw?
Kind of, yeah. It's the theoretical point where the entire weight of the aircraft is considered to be concentrated. The CG's location is absolutely crucial for the aircraft's stability and safety in flight. Think of it like trying to balance a ruler on your finger. There's one specific spot where it balances perfectly.
And the primary concern for you as a pilot is the fore and aft, or lengthwise, location of the CG, right? Not so much side to side.
That's correct. While lateral balance, the balance from side to side, is also important, especially in cases of uneven fuel loading.
Like if one wing tank is fuller than the other.
Exactly. But the longitudinal, fore and aft CG, is the primary concern for most general aviation aircraft. The CG isn't a fixed point, remember. Its location shifts depending on how weight is distributed throughout the aircraft.
So moving passengers or bags changes the CG.
Yep. As you move things around, passengers, baggage, fuel face, the CG will move accordingly along the length of the fuselage.
And the people who build the airplane define a specific range within which the CG must fall for safe operation.
Yes. Aircraft manufacturers determine and certify a forward and aft limit for the CG's position along the longitudinal axis. This is known as the CG range,
The safe zone.
the safe zone. It's vital for you as a pilot to ensure that the CG remains within these certified limits for all phases of flight.
What happens if the CG is outside of these approved limits for you? Say it ends up being too far forward, making the airplane nose heavy.
Okay, forward CG. If the CG is displaced too far forward, you end up with a nose-heavy condition. The handbook highlights that this can cause difficulty in controlling and raising the nose of the aircraft.
Making it hard to lift off or flare for landing.
Precisely, particularly during critical phases like takeoff and landing. You might experience excessive loads on the nose wheel or even a tendency to nose over if you're flying a tailwheel aircraft.
Ouch.
Performance-wise, a forward CG can lead to decreased efficiency, higher stalling speeds, and increased control forces required from you. You have to pull back harder.
More effort to fly.
Right. In extreme cases, it can even make it impossible to properly flare for landing, which is obviously a very dangerous situation.
That sounds pretty serious. What about the opposite extreme for you? A CG that's too far aft, making the airplane tail heavy.
Aft CG. That's often considered even more dangerous. A tail-heavy condition has a potentially even more serious impact on the aircraft's longitudinal stability for you.
Less stable. How so?
It significantly reduces the aircraft's ability to recover from stalls and spins.
Which you definitely want to recover from.
Absolutely. Those are dangerous situations you want to avoid. You'll also notice very light control forces.
Light controls sound good? No.
Not necessarily. It might sound good initially, but it actually increases the risk of inadvertently overstressing the aircraft by making overly aggressive control inputs.
Yeah.
It's too easy to pull back too hard.
Okay.
Imagine trying to balance a broomstick on your fingertip. It's much easier with the weight at the bottom. An aft CG is like moving that weight towards the top, making the aircraft inherently less stable and harder to recover if it starts to get out of control.
So neither a forward nor an aft CG that's out of limits is a good situation for you as the pilot. What about that lateral CG, the side-to-side balance you mentioned earlier? Is that as big a deal?
Well, while longitudinal balance is usually more critical, lateral CG is also important. This can be affected by things like uneven fuel burn from tanks on one side of the aircraft.
So one wing gets heavier.
Right. If you have a lateral imbalance, you might experience a wing-heavy condition, requiring you to constantly apply trim or hold control pressure to keep the wings level.
That sounds tiring.
It is. And it puts the controls in an out-of-streamline position, increases drag, and reduces the aircraft's operating efficiency for you. While trim can often compensate, it's not ideal.
It sounds like flying an aircraft that's out of balance in any direction can really take a toll on you as the pilot, both in terms of workload and safety.
Absolutely. The handbook mentions that flying an out-of-balance aircraft can lead to increased pilot fatigue for you. The constant need to compensate for the imbalance has obvious negative effects on the safety and efficiency of the flight.
Makes sense.
And, as noted, excessive trim to correct for longitudinal imbalance can further reduce aerodynamic efficiency and even limit the available primary control travel, potentially hindering your ability to control the aircraft in certain situations.
Less control range when you might need it most.
Mhm.
Okay. Let's dig a little deeper into these CJ limits for you. Where do these limits come from, and what factors influence where they're set by the manufacturers?
Sure. As we touched on, the forward and aft CG limits are established by the aircraft manufacturer during the design and certification process. These define the safe operating envelope for the CG location.
And they're official, right, in the paperwork.
Absolutely. They are published in the Type Certificate Data Sheet, TCDS, and the Aircraft Flight Manual, AFM, or Pilot's Operating Handbook, POH, for each specific aircraft model. If, after loading the aircraft, you find that the CG is outside these allowable limits, you absolutely must redistribute the weight before attempting to fly.
No fudging the numbers.
No getting around it.
What are some of the key considerations that dictate where these forward and aft CG limits are set by the engineers? Why there?
Okay, good question. The forward CG limit is often determined by the aircraft's landing characteristics. Manufacturers want to ensure that there's enough elevator authority for you to raise the nose for landing.
Enough control to flare properly.
Exactly, and avoid excessive loads on the nose wheel or the risk of nosing over in tailwheel aircraft. They generally try to place the forward limit as far rearward as safely possible to aid in preventing landing damage.
Okay, and the aft limit.
The aft CG limit, on the other hand, represents the rearmost position at which the CG can be located while still maintaining acceptable stability and control for the most critical maneuvers and operations.
So it's about maintaining stability.
Right. As the CG moves aft, the aircraft becomes less stable, and recovery from things like stalls becomes more difficult for you. So they set a limit you can't go beyond.
So these CG limits aren't necessarily fixed values for all situations, are they? I seem to recall reading that they can sometimes change depending on how the airplane is being operated.
You're right. They're not always static. For some aircraft, both the forward and aft CG limits can vary depending on the aircraft's gross weight.
So heavier plane, different limits sometimes.
Sometimes, yes. They might also be different for specific types of operations, such as acrobatic flight when the landing gear is retracted, or when carrying special external loads. It's crucial for you to always refer to the AFM POH for the specific CG limits applicable to your aircraft and the intended operation.
Don't make assumptions, check the book.
Always check the book.
And ultimately, it's you as the pilot who has the direct control over where that CG ends up through how you load the aircraft with passengers, baggage, and fuel.
Exactly. You directly control the longitudinal CG location through the placement of baggage and cargo, as well as the seating assignments for passengers.
Where people sit matters.
Oh, definitely. Even the location of the fuel tanks within the aircraft's design plays a role in how fuel burn affects the CG. For instance, in many small aircraft with fuel tanks in the wings close to the CG, burning off fuel has a minimal effect on the overall balance.
Okay, that's convenient.
But in other aircraft with fuel tanks further away from the CG, maybe in the fuselage, fuel burn can significantly shift the CG. You need to know how your plane behaves.
This all underscores the importance of actively managing weight and balance for every flight you take. What are some of the regulatory aspects and best practices you should be aware of as a pilot? Are there specific rules?
Well, yes. Title 14 of the Code of Federal Regulations, 14 CFR Part 23, lays out the requirements for manufacturers to establish these safe weight and CG ranges for aircraft.
So the manufacturers have to do this.
They do. This information then makes its way into the Approved Aircraft Flight Manual, AFM, Type Certificate Data Sheet, TCDS, or aircraft specifications, which are all critical documents for you. Now, Part 91, which governs most general aviation operations.
That's most of us learning to fly.
Right. It doesn't explicitly mandate weight and balance calculations before every single flight on paper.
Oh.
But, and this is a big but, it does require the pilot in command, PIC, that's you to comply with all operating limits stated in the approved AFM. And that absolutely includes weight and balance.
So the responsibility is still there?
Exactly. So while you might not always have to do a formal calculation on paper every time, you are always responsible for being within limits.
So even if you're not formally required to do a calculation on paper every time, you're still personally responsible for ensuring you're within those weight and balance limits before you take off.
Precisely. You have to know. To help you meet this responsibility, the AFM typically provides various charts and graphs to facilitate weight and balance computations. Responsible weight and balance control should be a primary concern for all pilots.
That's just good airmanship.
It is. You are the one who controls the loading and fuel management, which are the two main variable factors that can alter both the total weight and the CG location. Aircraft owners and operators also have a responsibility to ensure that up-to-date weight and balance information is readily available for your use.
Like if equipment changes.
Exactly. And that any changes to the aircraft's equipment are properly documented in the records.
What about those small, minor changes you might make to the airplane,
Yeah,
like adding a small bracket or something? Do those always necessitate a full reevaluation of weight and balance for you?
that's a good question. The Handbook, referencing Advisory Circular AC 43.131, provides some guidelines for negligible weight changes that typically wouldn't require a new weight and balance check for you.
Oh, there are rules for negligible.
Yes. These thresholds depend on the aircraft's empty weight. For example, for aircraft under 5,000 pounds empty weight, a change of 1 pound or less is generally considered negligible. There are also limits defined for negligible CG changes based on something called the mean aerodynamic chord, MAC.
Okay, so tiny changes are sometimes okay.
Sometimes. But any changes exceeding these negligible limits would indeed require a weight and balance check to ensure you're still within safe operating parameters. Best to check is onshore.
The bottom line seems to be that you as the pilot must be proactive and use good judgment before every single flight.
Absolutely. The handbook emphasizes that pilots should determine the weight and balance condition of their aircraft before every flight, using the procedures provided by the manufacturer. It's a matter of good airmanship and safety for you.
And it's not always possible to just fill everything up, is it?
No, definitely not. As we mentioned earlier, in many modern aircraft, it's simply not possible to fill all the seats, baggage compartments, and fuel tanks, and still remain within the approved weight and balance limits. You often have to make choices
Trade-offs.
and prioritize based on the specific flight. Maybe you need less fuel to carry more passengers, or vice versa. It's a balancing act you'll get familiar with.
Good to know.
It's also worth noting that Part 125 and Part 135 operators dealing with larger and commercial aircraft have more stringent requirements, including mandatory periodic weighing of their aircraft. Mechanics also play a role by checking weight and balance data during routine inspections.
Okay. There are a lot of specific terms associated with weight and balance that you'll encounter as a pilot. Can we briefly go through some of the key ones that a new pilot should be familiar with, just to clarify the jargon?
Certainly. Understanding this terminology is crucial for interpreting the weight and balance information provided for your aircraft. It makes the POH make more sense.
Let's start with ARM and datum. These sound like basic measurement concepts.
They are. The datum, or reference datum, is an imaginary vertical plane or line established by the manufacturer from which all horizontal measurements are taken. Think of it as your 0 point on a ruler for measuring the location of things in the aircraft.
The starting point for all measurements.
Exactly. The arm, or moment arm, is the horizontal distance in inches from this datum line to the center of gravity of an item like a seat, or the baggage compartment, or the fuel tank.
Okay, distance from the datum.
And by convention, measurements aft towards the tail of the datum are positive, and those forward towards the nose are negative.
Got it. Positive aft, negative forward. And then we have the center of gravity itself and the CG limits or range, which we've discussed quite a bit.
Right. The center of gravity, CG, as we've discussed, is the point about which the aircraft would balance. The CG limits are the specified forward and aft points along the fuselage within which the CG must be located during flight for safe operation.
It's the safe zone again.
And the CG range is simply the distance in inches between these forward and aft limits. How much room you have to play with.
What about moment? That sounds like something related to physics.
It is. Moment is the product of the weight of an item multiplied by its arm. Weight times arm.
Weight times distance from datum.
Correct. It represents the tendency of that weight to cause rotation around the datum. Think of it like leverage. Moments are typically expressed in pound-inches and are a key part of calculating the overall CG.
Okay, weight x arm, moment. Now let's talk about the weight of the aircraft itself.
Yeah.
We have basic empty weight, useful load, and payload. What do these tell you about the airplane?
Okay. Basic empty weight is the weight of the standard aircraft as it comes from the manufacturer, plus any optional or special equipment that has been permanently installed.
So the plane itself, plus installed options, but no fuel or people.
Exactly. It includes things like unusable fuel, the fuel you can't actually burn, and full engine oil. It's essentially the starting point for figuring out how much you can add.
Okay, the starting weight, then useful load.
Useful load is the difference between the maximum allowable gross weight of the aircraft and its basic empty weight.
Max weight minus empty weight.
Right. It's essentially what you have available to add pilot, passengers, baggage, usable fuel, and drainable oil. It's everything you can load.
And payload, is that different?
Payload is a bit more specific. It usually refers just to the weight of the occupants, cargo, and baggage you're carrying. Sometimes it excludes the pilot and fuel, sometimes not. Check the definition in your POH, but generally it's the paying part of the load.
Okay, the stuff you're carrying for the mission. And finally, some terms related to fuel and the overall weight limits. Fuel load, maximum takeoff weight, maximum landing weight, and maximum ramp weight. These sound like important numbers to know.
Absolutely critical numbers. Fuel load is simply the weight of the usable fuel on board your aircraft. Remember, about 6 pounds per gallon.
Right. Maximum takeoff weight.
That's the big one. Maximum takeoff weight is the maximum weight authorized for takeoff. You cannot legally or safely exceed this when you start your takeoff roll.
Cannot exceed. Got it. Maximum landing weight. Why is that different sometimes?
Maximum landing weight is the greatest weight the aircraft is normally allowed to have at landing. For some aircraft, especially larger ones, this might be less than the takeoff weight. It's usually due to structural limitations. The landing gear and airframe might not be designed to withstand the impact of landing at the full takeoff weight. You might have to burn off fuel to get down to the max landing weight.
Ah, okay. And maximum ramp weight.
Maximum ramp weight, also sometimes called taxi weight, is the total weight of the loaded aircraft, including all fuel and oil, sitting on the ramp before you start the engine. It's usually slightly higher than the maximum takeoff weight.
Higher. Why is that?
To account for the fuel you'll burn during engine start, taxi, and engine run-up before takeoff. So you start a little heavier, burn some fuel getting to the runway, and hopefully you're at or below max takeoff weight when you actually start the takeoff roll.
Makes sense. You should never attempt to take off above the maximum takeoff weight, though.
Never, absolutely not.
Knowing these terms definitely helps in understanding the weight and balance calculations you might need to do. Speaking of which, can you walk us through the basic principles behind these computations so we have a clearer idea of how it all works? How do you actually figure out the CG?
Absolutely. The fundamental goal of weight and balance computation for you is twofold. First, determine the total weight of the loaded aircraft and make sure it's not over the limit. Second, ensure that the location of the center of gravity falls within the approved limits specified in your POAAFM.
Weight and balance point. Check both.
Check both. The CG, as we've said, is the point where all the weight is considered to be concentrated, and for longitudinal stability, it's typically located slightly forward of the center of lift generated by the wings. The CG range, those forward and aft limits, defines the safe operating zone for this critical point.
And the calculations involve that all-important datum we talked about and the arm measurements to the various components of the airplane.
Exactly. The datum is your fixed reference point. The arm is the distance from the datum to any item's weight, pilot, passenger, bag, fuel. Remember, arms after the datum are positive.
And arms forward are negative.
Right. A station simply refers to a specific location in the aircraft, like a seat or baggage compartment, defined by its distance in inches from the datum. Then, you calculate the moment for each item.
Weight times arm.
Weight times arm. You do this for every single thing you're putting in the plane. Then, to find the overall CG of the aircraft, you sum up all the individual weights to get the total weight.
Add up all the pounds?
And you sum up all the individual moments, remembering negatives, to get the total moment.
Add up all the pound inches.
Then the final step, divide the total moment by the total weight. Total moment, total weight equals CG. The result is the location of the CG in inches from the datum.
And then you check if that number is inside the allowed range from the POH.
Precisely. You compare it to the allowable CG range for your aircraft, and you also check if your total weight is below the maximum allowed weight.
So it's all about making sure that total weight isn't exceeded and that the calculated CG falls within that specified forward and aft range provided by the manufacturer for the airplane you're flying.
Exactly that. And the handbook emphasizes that any sample loading problems you find in the AFM-POH are just examples for guidance. They're helpful to see how it works.
But you have to do it for your actual load.
But every actual loading scenario for your specific aircraft needs its own individual calculation to ensure you're within limits before you fly. It's also important to remember that external factors like high-density altitude thin air can necessitate reducing weight even if you're below the maximum gross weight.
Because performance suffers in thin air.
Right. It affects takeoff and climb performance. Runway conditions, such as a short or soft field, and any obstacles near the runway also need to be considered, as they can be further impacted by your aircraft's weight and balance.
And even for those smaller aircraft that might be less prone to being loaded outside of CG limits just because of their design, pilots like yourself still need to be vigilant about not exceeding the maximum weight. Is that fair?
That's a very important point for you as new pilot to understand. While some smaller aircraft designs make it harder to get the CG way out of limits, they can still easily be overloaded by weight if you're not careful.
Easy to put too much stuff in, even if it balances okay.
Exactly. So pilots must always verify proper loading, considering both weight and balance, for every single flight they undertake. Don't assume it's okay just because it's a small airplane. Always run the numbers or use the approved tools.
Now, the pilot's handbook touches on different methods for actually determining this loaded weight and CG of the aircraft. It's not always just pencil and paper, right?
Correct. The handbook outlines a few primary methods that aircraft manufacturers use and that you'll see in your POA-FM. The most fundamental is the computational method, which involved the step-by-step calculation we just discussed, listing weights, arms, calculating moments, summing them up, and dividing.
The classic longhand method.
Right. Figure 10 to 5 in the handbook provides a good example of how this looks on paper, usually on a worksheet.
And then there are methods that utilize information directly provided by the manufacturer to simplify this process for the pilot, make it a bit quicker.
Exactly. The graph method uses graphs provided in the AFM-POH. These graphs often help simplify the process. For example, you might find the weight of an item on one axis, follow it up to a line representing a station or arm, and read the corresponding moment off the other axis.
So the graph does the multiplication for you.
Pretty much. Then you add up the moments from the graph and use a separate CG envelope graph, usually a chart with weight on one axis and CG location or total moment on the other, to visually check if your total weight and moment fall within the allowable shaded limits. Figures 10.6, 10.7, and 10.8 in the handbook illustrate this visual approach.
So you plot a point and see if it's in the safe zone on the chart.
Exactly. Then there's the table method. This is another manufacturer-provided tool that presents weight, arm, and moment data in tables for various loading configurations, like standard weights for passenger seats, or pre-calculated moments for fuel levels or baggage areas, as shown conceptually in Figure 10 to 9.
So you just look up the numbers in the table.
You just look up the pre-calculated moments for your specific loading, like 2 front seat passengers, 1 rear, 50 pounds baggage, and sum them up. It can be quicker than calculating each one individually.
The handbook also mentions situations with negative arms and what's called zero fuel weight. Are those common complexities you might encounter as you get more experience?
They can be, yeah. A negative arm, as we said, occurs when an item is located forward of the datum, like maybe a baggage compartment in the nose.
Right.
And as the handbook points out with Figure 10.10, you need to remember that when calculating moments, a positive weight multiplied by a negative arm results in a negative moment.
So you subtract that moment from the total.
Correct. It pulls the CG forward. Zero fuel weight, illustrated in Figure 10.11, is the maximum allowable weight of the aircraft, excluding any usable fuel. This is a limitation for some aircraft, particularly larger ones.
Why exclude the fuel?
It's often related to wing bending relief. The weight of the fuel in the wings can actually counteract the bending forces on the wing spars in flight. So they limit the weight of the fuselage contents passengers' cargo to prevent overstressing the wing structure when there isn't much fuel in the wings, like near the end of a flight.
Ah, interesting.
So you need to ensure that the aircraft's weight without usable fuel doesn't exceed this limit. If it does, you need to reduce the weight of passengers or cargo before adding fuel. It's another safety margin.
Another number to check in the POH for your specific plane. Finally, the handbook discusses shifting, adding, and removing weight in the airplane. These actions all impact the CG, don't they? Can you briefly explain the principles involved for us?
Absolutely. These are practical things you might need to figure out. Shifting weight, like moving a heavy bag from the back seat to the front baggage compartment, or vice versa, changes the total moment, but not the total weight of the aircraft.
Because the weight is still on board.
Right, and therefore it shifts the CG. Moving weight forward decreases the total moment and moves the CG forward. Moving weight aft increases the total moment and moves the CG aft.
Makes sense.
The amount of CG shift is proportional to the weight shifted and the distance it's moved. The handbook even provides proportional formulas to calculate this shift precisely if you need to figure out exactly how far to move something to get back in limits.
What about when you're adding or removing weight, like when passengers get on or off, or as you burn fuel during a flight? That seems more common.
Right. When you add or remove weight, you change both the total weight and the total moment, which necessitates a recalculation of the CG to ensure you're still within limits.
So drop off a passenger, you need to know how that changes things.
Exactly. Fuel burn is a prime example of weight removal during flight. And you need to consider how the CG shifts as fuel is used, especially if the tanks aren't near the initial CG.
And the direction of the shift depends on where the weight change happens.
Precisely. The direction of the CG shift depends on where the weight is added or removed relative to the current CG. If you add weight aft of the current CG, the CG will move aft. If you add weight forward of the current CG, the CG will move forward.
Okay.
Conversely, removing weight aft of the CG, like burning fuel from rear tanks, will cause the CG to move forward. Removing weight forward of the CG will cause it to move aft.
So it's not just if you would remove weight, but where relative to the balance point.
Exactly. It's a dynamic system, and the CG is constantly changing, especially with fuel burn. You need to ensure it stays within limits throughout the entire planned flight.
It all comes back to that fundamental principle. Weight and balance is a dynamic consideration that you need to actively manage throughout all phases of flight, not just before takeoff.
Precisely. Operating within the weight and balance limits isn't just a recommendation. It's absolutely non-negotiable for flight safety for you and anyone who flies with you. You must always ensure that the CG remains within the approved limits from the moment you start loading the aircraft until you complete your landing.
So as you can see, weight and balance isn't just about crunching numbers in a book. It's about truly understanding how your aircraft behaves and ensuring a safe flight for yourself and anyone on board.
It becomes second nature after a while, but you always have to respect the numbers.
It's a continuous consideration from the initial pre-flight planning stages right through to carefully managing your fuel during your entire journey.
We've covered a significant amount of information today, and we sincerely hope this has provided you with a solid and clear foundation in the critical principles of weight and balance for your aviation journey.
Yeah, hopefully less dry now.
Always remember that your aircraft's POH or AFM is your definitive source for specific procedures and limitations related to your particular aircraft. Treat it like your best friend when it comes to weight and balance.
Absolutely. What are some of the common loading challenges you might anticipate, or perhaps have already encountered in your flying as you learn? What other aspects of aircraft operation are sparking your curiosity right now? We'd love to hear your thoughts and maybe address them in a future discussion.
Thanks for tuning in to Second Career Pilot. We look forward to sharing more insights with you next time to further support you on your aviation journey.
Thanks for listening.